what happens as a result of me saying, so I have this integer already, integer x, right? Okay, then I say I would like to have integer reference, say y equals x. What this does is this variable y, as we already said, is actually a reference to an integer, and what it means is that we simply give x the second name. Okay, it's a symbolic synonym, right? So beyond this point, right, essentially on a large scale of things, beyond this point in our program, in our code, x and y, which is already in scope, are basically the name for the same integer in memory, right? So you can duplicate names by creating an actual variable first, or just having similarly, I could have like an array of numbers in memory, and I could have initialized this y with essentially one of the elements in this array similarly. So this way I can have essentially y point to an integer in memory. It has to be an integer because it is declared with an integer type in mind, right? But it simply becomes another name for an existing valid memory location. Okay? So, and then the question is, why do something like this? We already know that we could use pointers which could be used as indirect access to existing objects. Why would we need a reference? Well, it's just a pure convenience, right? Pure convenience in situations like this. If I want to say void use integer, okay? And if I wanted to pass an integer to this function to do something with it, actually manipulate it, I could say integer value, right? Could say integer value, and over here I could, I don't know, maybe I could say value equals value times 2, right? I could duplicate the value, okay? But of course, when the parameter is passed by a copy of an integer, this is just a the value here is just a temporary copy of some other integer which is passed as an argument to this function, and therefore as soon as use integer function returns, the value thing is destroyed in memory. So if we actually wanted to use this value as access to an existing object, right? So over here I could say I don't know, just perhaps somewhere right here, I could say use integer, right? I could make a call. I could say use integer and pass x as my integer, and something's going to happen inside this use integer function, and it's not very interesting because it's very useless, right? The copy of x is made, use integer gets copy of the original value of integer, multiplies it by 2, stores the result back in the variable, and then function returns and the value is thrown away. So of course you can say, well, maybe you could use a pointer, right? You could say if you made this value actually a pointer to value, I will rename it to p-value. Then if we replace the name value with p-value and dereference each time we use a pointer, and dereference each time we use the pointer using the indirection operator, the asterisk in front of its name, then we will be indirectly referring to the actual integer in computer memory, right? So in this case, of course, what has to happen is that I need to pass the address of the variable to this function, because pointer needs to be initialized with an address of the variable. But look how much inconvenience this has created. First of all, I need to remember to declare this argument to this function as a pointer to an integer right here, number one. Number two, every time I want to use it and access the actual variable, I have to remember to dereference it by using the dereference or indirection operator. Plus, I have to remember to take address of my integer before I can call use integer. So the question is, could we go back to this syntax just like this and somehow indirectly access X without the hassle of the addresses and pointers and dereferencing the pointers and all of these extra steps and concerns that we had with use integer? So I'm just going to simply copy and paste Control-C and Control-V, and the answer is yes. If I declare this p-value, and in fact, now I'm just going to change it to, I guess, ref, to just be very explicit, to say this type of argument of use integer is using not an integer copy, not a pointer to an integer, but a new thing that we discovered today, a reference to an integer. Let's take a look at what's going to happen in this code. Nothing, just use reference as it was the second name for X, because what happens is that when at first when we look at the picture in the memory, right? Let me actually erase this and essentially redraw this a little bit, right? So we created an integer, we gave it some initial value, we created X, and then we figured out to give it a synonym, like eternal synonym names like Y and Z, which were basically giving you access to the same thing. But when it was inside the same main, local memory, it didn't make much sense. But now, when we call function use integer, right, and this time what I pass into use integer, right, so it gets its own stack frame to contain its local variables, it gets this reference parameter. But when we do it this way, when we declare that a ref is a reference, and the only time I need to do this, I need to say use this ampersand in front of the variable name, which makes it a reference to an integer. Okay, this reference becomes the just yet another name for this same integer, right? It becomes a synonym. So despite the fact that this reference is inside another function, it is simply referring back to the original object, and it's undistinguishable, right? Because look, if I somehow was able to get to X from this scope of this function, I would write X equals X times 2, right? Just using a normal variable syntax. Of course, X is not in the scope, but by using this reference thing, I can do this quite easily. And look, this second time I call this, the call will go to this specific function, which will use a reference, not a pointer, obviously. So it's going to call this specific function, this version of the function that takes the reference.